This is the fan of squares we want to draw. Obviously, this orange square that's the first square, and then 60 degrees to the left we have the second square, and then 60 degrees we'll have the third square, 60 degrees the fourth, the fifth, and the sixth square. They are all taken 60 degrees from one another. And that is basically if we evenly divide 360 degrees into 6, so we get 360 over 6, which is 60 degrees. Generally speaking, the angle that the squares are tilted from one another is basically alpha, which is 360 over n. That is generally speaking. Let's go ahead and implement this program. Okay, so first let's import turtles, so we'll be able to do all these graphics. Then let's ask the user for the number of squares. Let's read it, convert it to an integer, and store it in an integer in a variable named n. And then we'll have to draw a fan of squares. Let's decide size-wise that these squares are 100 by 100 steps. So in order to draw n squares, it seems natural to use a loop here that would repeat n times. Let's make this common draw fan of n squares 100 by 100, and then for count in range n, basically saying we want to make n iterations here. Count would have values 0, 1, 2, 3, up to n minus 1, total of n values. Each iteration will draw a square and turn left 360 by n. Let's implement both steps here. So the second step, turning left 360 by n, that's just calling turtle.left of 360 by n. And in order to draw a square, we basically need to move forward 100 steps, turn left 90 degrees, move forward 100 steps, turn left 90 degrees, 4 times. So instead of just sequentially having moving forward, turning left, moving forward, turning left, we can use a for loop here to repeat 4 times for I in range 4. Each time we'll just move forward 100 steps and turn left 90 degrees. So this for loop here would basically draw the square. So the body of the outer loop would then draw a square, and after that turn left 360 by n. After we're done doing that, we are hiding the turtle, calling the done function, and that's about it. Okay, so let's take a closer look at the implementation we just made. Specifically, let's focus on the inner for loop here that draws the square. So we made the implementation basically repeating 4 times, moving forward and turning left. If we do that 4 times, it definitely draws a square. But how about instead of having that a formal implementation, let's replace it by a call to the function turtle.square of passing 100 as a parameter. How about that? Doesn't seem more readable, more simple to implement? Obviously it does. There is just one issue with that, is that there is no square function in the turtle model. If there was one, we would definitely use it here. It makes the code much better. We see that n times basically we're drawing a square and turning 360 by n to the left. But unfortunately there is no such function. Obviously we can't use a function that doesn't exist. The good news is that for the first time, actually we're going to define our own new function. We're going to add a function to the definitions that we can use. We have been using functions, basically not defining functions, but we've been calling functions quite often. We've called the print function, we've called the input function, we've called some functions from the math model, from the turtle model. Calling functions is a thing we've done quite often. This is the first time, though, that we are defining a new function, adding a new definition of a function to our program. And that's exactly what we're going to do right now. Actually, we're not going to define a function inside the turtle model because we don't have access to make new definitions inside a model that is already released. But we can create our own functions in this current model. So it would be very much similar to turtle dot square of 100. We'll just create a function that doesn't access a model. It won't be turtle dot and then the name of the function. We'll make a function that doesn't have the dot notation in its name. So we'll create a function named turtle underscore square, basically, that as a parameter would get the side length. This is basically the interface we want from the function. When we are using the function, when we are calling the function, when I say we, basically I mean the programmer. When the programmer uses the function, they would call it with the name turtle underscore square. Again, note that we're using underscore, not dot, for the name, because we're not accessing the turtle model. We're creating our own function.